Okay, so let me just share my screen. Can you see my screen? Is it showing?
Yes, yes.
Okay, good. Okay, so today we are going to learn about dictionary. This is not going to be a long video. This is just going to be a very short video, a very short session. Okay, so so what are we going to learn today? We are going to learn about dictionaries. Okay, dictionaries is basically one of the types of lists, or basically types of how the way we arrange the data in a list. Okay, but instead of array, okay, where we have the index 1, 2, index, we also have index 0, and this is not the same. Dictionary, however, lets us use any key as an index to place our data. So for example, we want to put the key here is let's say name, and the data here is IIUM. So the name is going to be the index of our data in the dictionary that we have. So that's the difference. Why does this matter? Because from here, dictionary lets us use any input, any non-numerical input as our index in our listing. Okay. However, how do they deal with that? Okay. In This is where we come into hashing. Okay. So what do they do in the dictionary? We provide two things to a dictionary. So we have a key, we have a data. We provide these two into a dictionary. What do? They convert the key into an index, numerical index in the dictionary itself. Okay? And then we store it in the data that we have. But then isn't that the same thing as just isn't it easier for us to just provide the number of the numerical data of the student? Well, there is something different about this dictionary that an array cannot do. If somehow we have two in traditional array, you if you provide the same index, the index will be replaced. But in dictionary, if somehow both of your keys have the same numerical index, they can rehash the key again, meaning that they change the numerical index for the second time to obtain a new numerical index. Okay, for example, let's say uh, for simplicity, I'm just going to provide numerical input lah, numerical key as Danny. Okay, so for example, we have a dictionary of size 4. Okay, so we have index 0, 1, 2, 3. Okay, and then we want to provide the data to the dictionary. So what do we provide? We provide data equals to IIUM, and the key is 70. This this is what we call as something special about dictionary. You can give anything you want, and the dictionary will convert it into numerical index. Okay, rather than if you for array, if you provide any string input or garbage input, the program cannot convert it into numerical index. But in this case, I provide the key 70 to the dictionary. Let's say that this is the database, for example. So what do they do? In hashing, what do? We convert the key, we have the numerical key, we convert it to whatever the index that we have in the database. So in this case, I want to divide it by 4, which is the size of the database, and take the remainder. So what do we do? 70 modulo 4. Modulo means we divide the number with another number and we take the remainder. So 70 divided by 4 or modulo 4 equals to some kind of number with a remainder of 2. This is our actual index. From here, we put data IIUM here. IIUM, and we also put the key here lah. 70. Next, let us do another one. Data, let's say KOE. And I want to provide the key of 21. So what does the dictionary database do is that they took 21, they modulo it by 4, and they get some number with a remainder of 1. So, oh, my bad. This is supposed to be IIUM. And then the key is 70. And then for KOE, we put it here with the key is 21. Let's see what happens if there's a collision. So for example, I take the data to be DSA, data structure and algorithm, and the key to be, for example, 5. If we modulo 5 by 4, we get a remainder of 1. And if we notice that the index, the element at index 1 is already occupied. Okay, the slot at index 1 is already occupied. So this is where rehashing comes in. There are several ways that you can do rehashing, but based on what you have learned, what I remember that you have learned, is that there are 3 ways: linear rehashing, quadratic rehashing, and also linked list rehashing. So in this case, in this demonstration, I'm going to show you linear rehashing. Okay, for linear rehashing, let us change 5. Let us add 1. So from 1, we add 1. We got 2. Is the second slot empty? No. It is taken by IIUM data. So what do? We add another 1. And we get 3. Is slot number 3 empty? Yes. So we put it here. And don't forget, we also put the key here. Okay? But then, brother, why do you want to do this? Why do you want to do this rehashing and everything? This is because we want to make sure that we want to utilize every storage in that dictionary as much as possible. Okay. So that's why we don't care about we don't pretty much care about the index. We only care about the keys, how to hash it, and how to rehash it. Okay. So that's how we do it. Based on what I found about quadratic hashing, rehashing, and also linked list rehashing, what is different by the linear rehashing? The linear rehashing, we just add 1, the next one. If somehow, if we add 1, it gets more than the size of the dictionary, what do? We just loop back. We just modulo it by 4 again, or by the size of the dictionary. Same goes with quadratic rehashing. But for quadratic rehashing, instead of adding 1, we add n, if I'm not mistaken. Okay, we add n multiple times. And then if it goes through a loop, it comes back. Although, personally, I would prefer it to be times by n. I don't know why I found it that it should be add by n to the power of 2, but that's what I found. I prefer it to be multiplied by n, that is a coprime to the size of the dictionary. Also, although this is not included in the syllabus, this is just my personal preference. This is what I prefer for the quality hashing to be defined. But we'll just go by the book. And there's one more, which is the linear linked list rehashing. So what do they do? Instead of this stores the data, they stores the node to the data. So this is node 1. If somehow collision happens, it treats it as a linked list. So another node, node number 2, node number 3. This is basically complicated lah. Okay. So what do we? So for the sake of simplicity, I won't teach you how to construct a dictionary that uses linked list rehashing. Okay, I'm just going to teach you about linear rehashing. Okay, so far for the theory, is there any question? Anyone? No one. If no one, we'll proceed. Yeah. Let's see. Okay. Okay, so where do we begin? So what do we do? Dictionary, how do you want to include the dictionary? Is basically in Python, we do it like this. Dictionary, which is the name, whatever the name you want. You can put dictionary, or you can also change it to any names that you want. And then equals this. Instead of you put square bracket, you put curly bracket. Curly bracket, and then you see there's the key and there's the data. This is the dictionary that is implemented by the Python itself. Okay, so there's also another one, dictionary 2, print dictionary. How to get data? This is how we get. If you notice, we do not use numerical input, numerical keys. We use string keys. So if we run this, not this one, not the C4GUI, take the current file. See, if we print the dictionary, it will store it like this. And if you want to print the data, we just call it like this, dictionary, and put the key inside, enclosed by both bracket, not bracket, quote and quote. How do we update data? Similar to how we update the array. It's just that the difference is, instead of we put numerical index, we put key, string key. So dictionary name, we change it to CIE, and we print it again, we got CIE. If you want to add the data, we don't have to worry about the size of the data. I mean, in terms of the Python one lah, the Python dictionary. But if you want to do it ourselves, there is a way. We can make it ourselves. So let's say you want to add the lecturer, which is Dr. Rashida. So we put dictionary and we give the key lecturer, and the data, what is the data? Dr. Rashida. So if we print out, we get dictionary, quote unquote lecturer, and we got dictionary lecturer. Okay. And then how do you remove data? Easy. We just delete dictionary, and then we give the key to the data, to the dictionary. So we delete dictionary time. If I were to uncomment this, okay, let's see, and I want to run this, I will come into a problem, which is this one, because the key is removed. Okay, there are no key time. So this is what I meant by an error. Okay, dictionary clear, meaning that we are going to clear the dictionary, make it fresh and new. So if you print out this one, it will also give an error, which means the dictionary is empty. But if somehow we want to, we want to print out the dictionary itself, where we remove the dictionary, we clear out the dictionary, it is empty. Here, there you go. Now so this is the dictionary. My bad. This is dictionary. I'm supposed to teach you about hash table. This is hash table actually. This is hash table. So they call it a hash table kind of works like a dictionary. Uh, Actually, dictionary works like a hash table. So in hash, similar to dictionary, hash table lets us use any input that we want, or maybe we want to make this user give any string input that they want, and we can change it to numerical index. This is what you can use if somehow maybe you want to create a seed, right? A seed of a, if you want, this is just an application. You want to create a world or something, you create the person give you any string seed and then you change it to numerical input, which can be used for the random generation. But for hash table, it can be used for indexing. Okay, so let us learn how to do the hash table. Uh, uh, Change all this. This is dictionary, but this one this is the hash table. Let me just write it down. I forgot the term again. This is hash table, dictionary as well as hash table as well. This is also hash table because we are learning rehashing as well as this. Okay. Now, how do you want to implement this? So we create a class as usual, just for the demonstration. So define initialize self size self.size equals to size self.keys. So this is the part where we time the size. Okay, we set the size of the hash table, which is not which is different than dictionary. Dictionary have no size, but hash table we can set the size. Okay, so what do? We introduce an array of keys and we introduce an array of values. But both of these are in an array with a numerical index. Okay, as you can see, we can see that there is a hash where we take the key from the user, we hash it and we change it to, we hash it by modulo it into size. If somehow there is a collision, we rehash it, meaning that we add it by 1 and we modulo it again in case of it going loop another for it to loop around this the array. And then this is the part where we want to get the data from the key. So what do? So we take the index, okay, by hashing the key. So index equals to self.hash key. If the index is found immediately, so we return the value of the keys, the value at the certain position. Somehow, if the key is not found, okay, so we have to go through the table, through the hash table to find the key. So what do? We take the OG hash, meaning that the original hash equals to index, and then for the index, we rehash it, meaning that we update the index to get another value. Okay, so we loop around. While index is not OG hash, meaning that if it does not return to itself the same position as before. Okay, so if the key is found, then we return self values dot index. Else we return none. Okay. Actually, why do I put return none? It is supposed to be this one. Index equals to self.rehash, because we want to rehash the index many times. And then at the end, what do? Return none. Okay, that's all. And then if you notice, we have another one which is called get item. This is basically we want to treat it as an array. I'll I'll get to you. I'll get to you when we come down here. Okay. And then if you want to put the value, okay. Def put self comma key comma value. Index equals to self dot hash key. That's basically the same thing. So if the index position has no key or has the key or the same key requested, meaning that if that position is empty or it has the same key as what we ask, so we update the key. We update the key and we update the value. We put it inside the value. Okay. In other words, let me just give you the demonstration. For example, let's add this and we'll copy this. Let's erase this. Okay, this is what we have just now. Now we are going to get the data. We want to update the data. For example, I want to change. I provided the key 70, but I want the data to be, for example, CIE. Okay. So when we hash 70, we hash it, we get 2. So we check position number 2. Oh, the key is the same. So meaning that, so the program understands that we want to change the key, change the data. So it changes from IIUM to CIE. That's how it works here. However, if it does not, it is the same. So we have to go through the table to find the empty spot or the key. So OG hash equals to index equals to step-free hash, while index is not OG hash. So basically we loop around the table and to find if there's any empty spot or if there's a key. Okay. However, if somehow the table is full, then what do? We just say the table is already full. That's all. And define set item self comma key comma value. Basically, this is if you want to put the value here like this. Okay. If you want to print out, this is what it means by comma underscore get item underscore. This is what we meant by underscore set. Is it set item? Set item underscore like that. Okay. And if you notice, I put the default def delete here, but I did not show you because basically it's the same thing. You check, you hash the key, you check, or if there's a collision, you loop around the table. If the table is full or the key is not found, so you say the key you are requesting is not found. If it is found, then you delete the data as well as the key. That's all. And how do you run this? How do we run this? So you can see we have the hash table 98. So let us see. Hash table 7. So the size is 7. Okay. And we put the H1's ECIE. So you notice ECIE, we print out the keys and the values. So at index 1, we got ECIE. At index 98, notice that 98 is IIUM. The key is 98, and the data is IIUM, but it's on index 0 because the index is 0. KOE 20, the index is how many? Is it 6? 6. And DSA, which is 5. And then we change it. So H5 equals to lab. So what happened? it puts here. And a Python 7, it puts at the where? It puts at number at here, at the empty slot. It does not replace IIUM. Because the key is different. Notice that. Okay. And then we set item here ECIE PHP. Let's see. C++. So 10. Let's see. There's one empty. Okay. So there's one empty set item. So you put C++ here. And you notice that H20, it is the same key as KOE just now. So what do? We replace the value KOE to PHP. And if we want to print again, we got ECIE here. And we have PHP here. Like that. If we print out 30, there's no key, there's no index that have the index 30. So we just remove it. Okay. So, is there any question? Meanwhile, let me just let me just drop out give you the magic word. So the magic word here is this hash this table. Maybe I should put it in notepad. There you go. Okay. Now, is there any question while you guys filling up the Google form? Anyone?
No question.
No question. Are you sure that you guys have no question? Brother, how do you want to hash the strings? I mean, it's up to you. I can show you. Let us take this. Copy this thing. And let us change this one. This is the linked list previously. Let us change how do we want to hash the key. Meaning that this time we want to hash strings. Okay, so instead of we do it key hash self size, let us take a string, convert it to a numerical value, and then we how do you call it? We give it back. We use it for our numerical index. So for the sake of ni, so h equals to hash what hash table 7 as usual. So let us just say again name equals let's see IIUM uni name university IIUM. Let's copy this, change it to what do you call it, kuliah KOE. And then we have what do you call it, country, since we live in Malaysia, so let's put country Malaysia. What more? Lecturer, for example, Dr. Rashidah. And then another one, course. which is ECIE, or maybe data structure and algorithm. Okay, so we have these three. So how do you want to change this string keys into numerical keys? It's on your creativity. You want to change the first letter of the universe of the key and make it turn it into a numerical key, also can. You want to do it like, for example, change every single letter into a numerical equivalent. For example, U is, I don't remember, A is 1, B is 2, C is 3, and then you add them all together, and then you what do you call it, you modulo it, also can. It's all on your creativity, but for me, I'll just take the first value. Okay, so numerical key equals, let's see, int. Was it int? Let me see. Let me just recap myself how to change string to a number, to its equivalent number, actually. This is where Stack Overflow comes in. Okay, this is where Stack Overflow comes in. Character, I mean letter to number, Python. Good. Ordinal, and then we take the key 1 as 0, meaning that we take the first numerical key, the first letter of the key, and we output it. So for the sake of this, let us add another one, self dot numerical key equals, just for the sake of you, I want to show you guys what is happening behind the scenes. Time size. Okay, and then let's see, key index hash key, so index hash key. Okay, so it returns that one. Okay, this is get item. I want to put the item, so we put this one, self dot keys, numerical key, I mean numerical keys index equals to self dot hash key, like that. Yes. Okay, good. Yep. So we've done that. Let us print out everything. So print h dot values, and then print h dot keys, and another one, print h dot numerical keys. So if you run this, see, so we have cost, university. Why is the, let's see, lecturer, How on earth is this not? Let's see what happened to the data structure and algorithm. Oh, I forgot. I forgot to add another one. There you go. You notice that the country and the cost collides. Okay, the key country and the key cost collides. So what happened? They have to use what do you call it? They have to use not collision. They have to use rehashing to update the index so that we can find an empty space in the array in the hash table, and we put the data structure and algorithm here. So this is how you do string hashing. One of the string hashing lah. There's so many ways you can use what I suggested before. Okay, so is there any question left before we go to the task? I will update the what they call it, the GitHub, because there are every semester I'm keep adding more and more to my code, so it's get a bit better. Just because I did not do the coding in front of you, so I just want to add some more. So let me see the task for a bit. Okay, so I guess this is another housekeeping announcement. So now for task 2, I will not check your coding again. Okay, I will not check your coding since it's already chapter number 4. As for task number 3, I will check after this and I will update the carry marks sheets for you guys to see. Okay, so if you notice that there are three different what do you call it? Three different lists, three different tasks, so that I can see what are you guys doing. So if you guys got one of them, you guys exceed on one task, I give full marks, and so on and so forth. And for task 4, so I've given you how to hash. Okay, so this is how you can do it. It can hash only string keys. It does by taking the first letter. All of them are lowercase. Can change to a number according to the alphabetical order. So A is 1, B is 2, and so on. You don't have to worry about numerical keys. Okay, so we are not going to give any numerical keys. You also don't have to worry about special characters, because if you see the appended code, there are no special characters. Okay, it uses linear hashing whenever collision happens, and it must contain set item and get item functions. Because why? If you notice, I have this. You cannot you must use square bracket for putting data or get the data. Okay, and then the last one is delete the value inside the hash table using its key as the parameter. Actually, I want to make it even harder. Maybe I should add another one, which is clear function for the hash table, because so you can basically the same thing. You just clear the table, okay? But I won't do it in this semester since I just thought about it. But in the next semester, good luck. Okay. Is there any questions you wanna ask? I think I can stop the recording now.